my name is Jerónimo Ortiz. I am a DevSecOps engineer at scanoss. Today I'm going to talk about scanoss tools primarily and do a quick demo at the end of the presentation so you can see some of our tools and technologies in action. scanoss is a software composition analysis disruptor. And why is it a disruptor? So we try and differentiate ourselves from our competitors in the SCI market by having a business model based on committing to the open source, being transparent, and avoiding vendor locking practices at all costs. The company is remote only, and it's based in Madrid, Spain. At the time of this presentation, we are composed of more than 30 staff. So scanoss is a data company. What does that mean? So the value of scanoss is in its IP, which is the scanoss KB, the single largest open source software knowledge base right now. So just to give you an idea of what I'm talking about, the scanoss KB is currently more than 20 terabytes in size. So it's a pretty large knowledge base. Diving a little bit into our business model, our target market is open source software intelligence at scale, which is usually big corporations from multiple industries such as electronics, automotive, telco, and so on. And I want to dive a little deeper into what I meant by saying that we are committed to the open source. So scanoss offers 100% free and open source software development in the open. So scanoss software is published to our GitHub organization, and you can see all of our development process there. And by the privacy by design, I mean that we are guaranteeing data privacy, and you will see the technical aspect of that later on with the demos. So despite data and the scanoss KB being our source of income, we publish all the necessary tools and information required to build your own knowledge base, and that results in zero vendor locking. We also participate in several open source projects, vendor neutral forums, events, and we are founding members of the Software Transparency Foundation. And also, as part of what we call our journey towards open data, we published 2 open datasets, which are crypto algorithms open dataset that include a curated list of cryptographic algorithms, and Pool to CPE, which contains relations between CPEs and pearls. Then, what is the Software Transparency Foundation? So this is an EU-based foundation with the mission of solving software supply chain transparency. As part of their numerous initiatives, they offer osskb.org. That is a free of charge service that enables open source upstream developers and projects to create complete SBOMs through scanoss and/or third-party tools. osskb.org provides access to OSSKB, which is the open source software knowledge base, through an open API developed by scanoss. And the OSSKB and scanoss.py share a few things. So file and snippet level scanning of open source code, detection of declared and undeclared open source software in your software, and the licenses dataset that includes detection of license obligations, compatibility, copyright notices, attributions, and so on. This is supported by every language. So with that out of the way, we can jump on to the open source SCA tools published by scanoss. So these are the main points of scanoss. So development in the open, I already talked about that. All this presentation has lots of links, so maybe later on I can share it so you can explore all the resources. Zero vendor locking, I also explained, so the possibility of building your own knowledge base with scanoss technologies. and using scanoss or third-party clients, scanners, and open APIs to use your own KB. And as I told you earlier, this is the privacy technical part. So scanning logic in scanoss works in a way that users are scanning their code against scanoss KB and not the other way around. So this is achieved by using hash-based matching of your code. So you aren't even scanning your code, just code fingerprints, which are winnowing algorithm checksums, very lightweight. We call them code fingerprints, right? So other important point is the extreme flexibility. scanoss is API based. That means users, developers can use scanoss tools, third-party tools, or even create their own tools and integrations, right? Here is a chart of our tools. So we have a few sections. Starting from the top, going down to the bottom. Miner is the tool we use for data mining to create our own KB. This is also published for everyone. And this is one of the tools that you can use to create your own KB. The engine is part of our server stack. So you would need to have the scanoss engine running on your machine to be able to leverage your own knowledge base in this case. If you choose to scan against OSSKB, you wouldn't need neither engine or miner. Our open API is also published. LDB is the data structure we use to store our knowledge base. So we had the need to develop our own database system because for the size of our KB, queries of that amount of items and size would be almost impossible. So LDB, we call it a database management system, but it's more like a data structure. So that is better for scanning speed. And then we had SDKs. So we have a Java SDK. We are constantly updating at the moment. We also have Python, and JavaScript SDK. Then we have CLIs in Python, Java, and JavaScript as well. Then we have the SBOM Workbench, which is an auditing platform with a graphical user interface. We have CI/CD integration for major platforms such as Jenkins, SonarQube, GitLab, GitHub Actions, and so on, and extensions for developers, so IDE plugins and desktop applications. So from the last time we presented here, this chart was one of the part of the feedback we received because it explains more the architecture of scanoss. So each of scanoss or the Software Transparency Foundation servers hosting the OSSKB in this case have the scanoss engine, the API, and knowledge base on them. The engine handles the scanning matching logic. The API allows users to query the service, and the knowledge base contains the information for users to scan against. Mining servers use Miner and LDB to mine data from different sources, such as GitHub, NPM, and so on, and build and update the KB accordingly. Then the user queries the scanoss API with their software of choice, so either scanoss, third party, or else, and gets the scan results for their code. So now, sorry.
Can you go back to the diagram?
Yeah.
Yeah. Now that I see it, you mentioned before that you can use third-party tools, and yeah, now that I see you presenting it, they are not there. It might be a good option to put the third-party tools, or at least a couple of examples that. Because in the client side, I just see the scanoss ones, but we put there, the Fossologies or RTs of the world that are already consuming the API.
Yeah. So, sorry.
Yeah. Okay.
I will share links of the most common third-party tools you can also use scanoss with, which are ORT, Fossology, and Fosslite. I can then show some documentation about that. And jumping to the demos, I have 2 demos prepared for today. So the first one will be using the scanoss Python client, scanoss.py, and we will be scanning source code for declared and declared OSS components and dependencies, and then generate an SPDX Lite SBOM. So if I can jump to this, let me know if you can read the terminal or
Yes.
on size. Okay. Okay, so the scanoss Python client is a CLI, also free and open source to use. It's published to PyPy, so you can install it by running pip install scanoss, and there's not more configuration other than that. So for today, I prepared a few repositories. So the Vue.js library on the core folder, the MetaRisk5 repo, and setlib. So we can scan a few projects, different projects, right? So the command for scanning source code would be scanoss py scan, and then the folder of choice or file of choice. In this case, we can scan MetaRisk5 and trigger the scan. A quick reminder, I didn't said previously, this demo, as well as the other, will be done using OSSKB, which is the STF published free open source knowledge base, right? So the speed, as I was telling you, was quite speed, right? Quick. So this scan was for, I will tell you how many files. Sorry, so 187 files in about 2 seconds or so. So here I'm showing you the raw results of the scan. So this is not on a standardized format. This is just JSON. This is not an SBOM, so this is just a JSON of the scan results, where we can see, for example, for this component, MetaRisk5, we are looking at the file we have locally, the file hash I was telling you about when I was talking about privacy, the URL of the file on the KB, the type of the match. So this is a file match, not a snippet match. And then we can see information about licenses. Down below, we can see the match percentage. So this being a file match, it's matching 100% to the original source code, open source component, sorry. And the package URL, information about the KB, and so on, right? Then for creating our SBOM, we support different formats. So for example, SPDX Lite and CycloneDX. For this case, we'll do a SPDX Lite software bill of materials. So we can use the same command as before, but we can add the flag -f and the format of choice. So SPDX Lite. Sorry. Was without a dash. So here we can see the SPDX Lite SBOM, right? Right here it starts. So the typical specs, date license, ID, name, and so on. So this is for scanoss py. I'll be answering questions later during the Q&A section. But yeah, we can jump to the other demo. which is a CI/CD integration demo. So the use case for this one would be to automatically detect and block pull requests containing undeclared components, dependencies, or copyleft license code on a GitHub repository, right? The tools and services that we will use during this demo are osskb.org again, and the scanoss code scan action, which is a GitHub Actions integration we published. And I will show you how the setup looks like and a demo of the integration working. So we can go to the repo I prepared for this presentation. The source folder, we have some source files I selected here. So just to do a quick note, the clients and API calls you can do from your own machine have a speed of it's limited by your server's machine, right? So it will be much faster than running it from GitHub, which uses GitHub speed. So it will not be as quick as if you run it locally, right? So that's why I grabbed a few files instead of a few hundred. Then on the .github workflows, we have the YAML file for this action. So this is already published. You have a few options to configure this. So adding the policies right here for copyleft and undeclared components detection and dependencies scanning as well. Here you can either use the API key for scanoss service or don't use it and use OSSKB as a default, right? So I will do a quick pull request from a branch that we will call dep, right? For example, I would just add a space right here, a blank space, just to do a commit, right? So let's say update, for example, commit. Then we can go to the repository and create the pull request. And you can see that the action triggered a few checks. So checking for the copyleft licenses on the code, undeclared components policy also, and dependency scanning that we will see in the raw JSON output that this action produces. So I added a quick note on speed because of this. So just so you know. Okay, some checks failed here. The undeclared component policy failed, and why is that? So it detected a few undeclared components. So the logic behind this integration is having an SBOM JSON file to keep track of your open source components in your project. And in this case, it's detecting that these two packages, so DMD and klibc, weren't in that SBOM JSON file. And for that, the policy is failing. Then no copyleft licenses were detected here, so that policy passed. And on the summary for this action, we can see a licenses chart. So the licenses detected here, and they are not copyleft. And if we go below, we can see the artifacts this produced. So the results JSON raw output I showed you previously with scanoss.py, and Markdown, which represents basically this chart and this table for the policies, right? So you can use this integration, as I said, with OSSKB or scanoss.py as you prefer, and use it right now. So yeah, that's pretty cool.
Can you use it for your own knowledge base?
Yes, you can. Yes, you can. You would need
What,
to
what,
go.
what would I need to do?
So basically, you would need to first create your knowledge base with miner and LDB, as I explained previously, and then I can show you on the workflows part. So it varies on the setup of the user, but right here you have the options to add an API URL of your hosted knowledge base. And if you have API key authentication set up, you can also use the API key option, right? These are all of our resources right here, and also the STF links. As I told you, I will be sharing the slides. Oliver, you then tell me from where I can share them, so you have them available. And yeah.